Question number 3 is from chapter Quantization of Light, chapter 9 of this semester. We have the condition or the question, a light of wavelength. So remember, light is also called as photons. Is shown on a sodium metal surface in vacuum. Okay, so this is our metal, sodium metal surface. Calculate the energy possessed by the photon of light. Okay, we may imagine this is the metal surface, okay, in the vacuum. Then we have the light shine on the surface. So we hope that you still remember photoelectric effect. Okay, this is the phenomenon of photoelectric effect. Okay, what happens when we shine the light on the metal surface? Okay, it's going to be photoelectrons will be emitted from the metal surface. Okay, to answer A, okay, we just need to calculate the energy for the photons or the light. The equation is hc over lambda. So substitute h 6.63 times 10 to 34. C is velocity of light times 3 times 10 to 8 over lambda 436 times 10 to minus 9. Then your E is supposed to be 4.56 times 10 to minus 19 joule. Okay, the second question is to calculate the work function of the metal, provided here the maximum wavelength is 650 nanometer. So basically the maximum wavelength is 650 nanometer is required to free the photoelectrons from the metal surface. This is actually the definition of lambda naught, okay, threshold wavelength. So to calculate the work function, we have the equation W naught is equal to Hc over lambda naught. So again, we do the substitution, times 10 to minus 34, 3 times 10 to 8. So your threshold wavelength is 650 times 10 to minus 9. So your work function is supposed to be 3.06 times 10 to minus 19 joule. Okay. And the last question C, calculate the maximum energy of the photoelectrons. Okay, so now we're talking about photoelectrons. So this one is about metal, E, W naught. So this one is K max. Okay, photons, metal, and photoelectrons. So calculate the maximum kinetic energy of the photoelectrons extracted by irradiation of 36 nanometer. So we have the original condition. So we have the Einstein photoelectric effect equation. So your K max is basically equal to energy of the photons minus the work function. So we have got the two values from A and B. Now we just substitute. Okay, we just use the values times 10 to 19 minus 3.06 times 10 to 19. Then your answer will be 1.5, okay, times 10 to minus 19 joule.